Hi everyone, today we are going to see an important topic in machine learning which is called Gini Index. So Gini Index is a measure which quantifies the purity of a parameter in machine learning. Okay, so the purity of a parameter, when we require a purity of parameter, so main application of this Gini Index is in decision tree. So whenever we have a decision tree, something like, let's say some example, somebody's age is less than 30. Let us take an example. He eats pizza. Then the other side you take, he do exercise. Eat pizza, yes. Not fit, no. Consider fit. Do exercise, yes. Then you can consider him as fit, no. Not fit. So like this, sometimes you need to create decision trees in machine learning algorithms. So here the question is how to create decision trees. So decision tree uses an algorithm called cart. To create a decision tree, we'll use something called cart. What is cart? Cart is classification and regression tree algorithm. Classification and regression tree algorithm. So this classification and regression tree algorithm will be using this Gini index to choose the root node. Here we have root node is age, and we have three parameters. One is age, two is eat pizza, third one is do exercise. Which one to be chosen as root node? So now we have three parameters, P1, P2, P3. Let's say now we are going to find out what is the Gini index of P1, what is the Gini index of P2, what is the Gini index of P3. After calculating all the Gini index of all the parameters, now whichever parameter having lower Gini index will be selected as root node in decision tree. So now let's take an example and see how to solve this, a Gini index. So now let's say I'm having a class of students with 8, 9, 10 and 11, and the parameter I'm staying it as stay in hostel, whether the students stay in hostel or not. Then what is the total count of students and what is the probability he stays in hostel, what is the probability he not stay in hostel. So let's say two students stay in hostel and one student not staying in hostel. In 9th class, no is equal to 1. Randomly we are taking an example. S is equal to 1, no is equal to 3, S is equal to 3, no is equal to 1. So what is the count? Here the total number of students is 3, 3, 4 and 4. So now what is the probability that a student of class 8 stays in hostel? So the value for S is 2 and the total count is 3. Similarly, the probability S is 2, total is 3, 1 by 4, 1 by 4. Now here we are going to see 1 by 3, 1 by 3, 3 by 4 and 1 by 4. This is how we are going to calculate these values. So now we are going to calculate what is the Gini index for these values. So what is the Gini index we are going to calculate for each one of it. Here we are going to calculate the Gini index of class 8. Gini index of class 8 is, the formula is 1 minus probability of S square plus probability of no square. So what is the value if you want to substitute here? P, the value is 2 by 3, 1 by 3 whole square. G of class 9 is equal to 1 minus 2 by 3 whole square plus 1 by 3 whole square. So I'm just writing directly the values 4 by 9, 4 by 9. Similarly, we are going to calculate class 10 here, which will come to 16. G of class 11, which will come to 6 by 16. So now we have calculated individual values. Now need to compare Gini index for the for all the students. What is the average of all the students? So the entire college or school we are going, the entire school we are going to find out. So how to find out? So Gini index of school is equal to, the formula is number of instances in class 8 by total instances into G of class is equal to 8. Then plus the same thing into G of class is equal to 9, plus the same into G of class is equal to 10, plus same into G of class is equal to 11. So what we are going to get is number of instances in class 8. So how many number of instances in class 8? The total count we have, the total instances is 3. And what will be the total instances? This instance, the total number of instances in class 8. And what will be the total instance? Total instance is the entire total. So the entire total is 14. So what we are going to get here is 3 by 14 into 4 by 9 from here. G of class 8 is 4 by 9 plus 3 by 14 into 4 by 9 plus 4 by 14 into 6 by 16 plus 4 by 16 into 6 by 16. So whatever the value that we will get it here, the value, let's say this is V, this is our Gini index for variable called class. Let's say it is 0.8. Let's say it is 0.8. So now if we have multiple parameters like, so now we got Gini index of class, we got that is 0.8. Similar way, if we have one more parameter that is equal to gender, how many male are staying in hostel, how many female are staying in hostel, let's say it came to 0.9. So now we have to compare which one to be the root node. Now we have to compare these two values in this. So the Gini index of class is lesser value, hence the class is chosen as root node. So this is how we are going to see use Gini index in decision tree. That is, in CART, decision tree uses CART algorithm, CART uses Gini index algorithm to find out which one is the root node.